I apologize in advance if this video is so weird that you never wish to interact with me ever again. So, calculus. It's difficult. Some parts more than others, but if you struggle with it, it might be worse for you. Studying is hard, and learning causes pain, and you don't want to go on Wikipedia to look it up because their stuff makes no sense. But as long as you have competent teachers, you should be, at the very least, semi-decent. Anyway, old L'Hopital's. So, we all know how to take the limit of a function, right? Right? On the assumption you know, it's fairly easy. You just put this and that, and ta-da, math happens. Or calculus, specifically. But what happens when we get something like this?
Right.
Oh, and this one's even worse. Crap. So, we just give up, right? The answer? Yes. Oh wait, there's still this. Never mind. L'Hopital's was invented in the late 17th century by Swiss mathematician Johann Bernoulli. Ha! Bet you didn't see that one coming. And attributed to Guillaume de L'Hopital, who published it in his book That Thing, which is the first textbook on differential calculus, and this isn't really relevant, I'm digressing. Moving on. Basically, when we're faced with a situation that the limit of a function is an indeterminate form, aka 0 over 0, or infinity over infinity plus or minus, L'Hopital solves these dilemmas by taking the separate derivatives of the numerator and the denominator and taking the limit of that. So, going back to the examples, the limit as x approaches 1 of ln of x over x minus 1. You take the derivative at the top, you get 1 over x. You take the derivative at the bottom, you get 1, which ensues that the limit as x approaches 1 of 1 over x over 1 equals 1. Yay, determinate forms.
Victory screech!
And now let's look at the other example, which was the limit as x approaches infinity of e to the x over x cubed. You take the derivative of those, and you get e to the x over 3x squared. Still getting indeterminate? L'Hopital's again. You take the derivative of that, and you get e to the x over 6x.
The end is near.
Infinity over infinity? L'Hopital's. You take the derivative of that, and it equals e to the x over 6. And now, you can take the limit. E to the infinity over 6, blah blah blah, blah blah blah, blah blah blah. So yay, a new rule for solving limits. But you cannot use it for everything. If the limit as x approaches a of a function equals something over 0 or something over infinity, L'Hopital's does not apply. The answer is undefined. And that's when you give up. You're welcome. All jokes aside, this is how you actually spell it. Mom, don't do that! Mom, stop! Mom!